Okay, so in this particular video, we're going to find a value of an annuity and find the interest gained on that annuity. Now, an annuity is, or annuities are insurance contracts that provide a fixed income stream for a person's lifetime or a specified period of time. So an annuity can be purchased with a lump sum or a series of payments and begin paying out almost immediately or at the point in the future. So annuities are often used as a way to fund retirement. Okay, so that is kind of what an annuity is. Okay, so now how do we do? What's the problem I'm going to give you? So we want to do, the first part is I'm going to give you some information, and then we're going to calculate the appropriate the value of the annuity and the interest. So let's do the annuity, the value of the annuity. I'm stumbling over my words here. All right. So the first thing we're going to do is we're going to find the value of the annuity. Okay, and the periodic deposit is going to be, means every time we reach a year, we're at the end of the year, we're going to deposit, period deposit here is about $8,000. At end of year. Just kind of shorten the sentence. End of year. And then the rate is going to be at 4%. So we'll do 0.4. And then it's going to be compounded annually. So N has to be 1. And for 30 years, it's going to be T equals 30. So the formula that we're going to use is the following. Okay, so if it's compounded more than once a year, hold on one second. More than once a year, we use the following formula. Okay, it looks complicated, but it's not. That would be the appropriate formula. Okay, that we use on this situation. So we know P is going to be 8,000. All right, we already know the value of the rate is 0.04 that we put here on top. And the time is 30 years, so now we just substitute everything in there. Okay, 1 plus, all right, the rate is 0.04. Gonna raise that to the 30th power. Okay, minus 1. Hold on one second. Let me write this. Okay, here we go. All right, so I'm assuming you know how to handle these calculations. You know, you do 1 plus 0.04, you get 1.04. You raise that to the 30th power, and then you subtract 1. you'll get a number and you times it by 8,000. Okay. You get a number here from all of this. And when you do that, you will get a value of $448.680. Okay, so that's what the annuity will be if you deposit $8,000 at a 4% interest. So, of course of a lifetime, you'll get a nice little retirement, which is just under $500,000, right? Not bad, but $8,000 a year must be contributed, which is a good high amount. Okay, now we want to find the interest. All right, so here's another situation. We are going to calculate the appropriate, we're going to find the value of the annuity and then calculate the interest, okay? We're going to calculate the interest for this problem that we have in front of us now. Okay, so hold on. So going back to what we calculated, we have to divide 1 plus 0.04 to the 30th power minus 1. We need to divide that by the rate, which I forgot to do, which will be 0.005. So make sure that we, go back here and let me just correct that, okay? All right, so it's going to be 1 plus, let me just do it right under here. We need to divide this whole thing by the rate, which is going to be at 5.5%, or I should say 4%. So it's got to be like this, okay? So after you do that, after you do 1 plus 0.04, which will give you 1.04, raise that to the 30th power, subtract 1, then divide it by 0.04, you will get a value of 448,680. That's what the real answer is when you divide by 0.04. So that's what you get after 30 years. The interest is going to be the difference between the value of the annuity and the total amount deposited. So the value is going to be $448,680, and we're going to subtract the total amount that was deposited. Now the trick here is if you're depositing $8,000 over 30 years, that's going to be 8 times 30, which will give you $240,000. So when you take the difference, you will get $208,680, and that's what the interest will be earned on that. So keep in mind that this number here is you have $8,000 deposited every year times 30 years will give you the $240,000. So we need to figure that out before we take the difference of the future value. Okay? Okay, so now we are going to use a couple more situations, and it's going to be the third one is going to be this. Let's find the future value of the annuity if it's compounded monthly over 40 years. So what we have to keep in mind is the interest is compounded more than once a year. Okay, which is which actually it's each month. Tripping over my words. So it's going to be more than once a year. Okay, and so we got to keep in mind that n has to be 12. Okay, so we have the initial information is going to be given. The periodic deposit will be $30 per month. The rate is going to be 5%, so 0.05. Time is going to be 40 years. Okay. All right. Let me see if there were anything else. And okay. So if it's compounded monthly, then n has to be 12. All right. And then when it's more than once a year, we need to use the following formula. Okay, which is going to be P. Okay, so A is going to equal P times 1 plus R over N. Divide that by R over N. Okay, so it's just a matter of plugging in the information and calculating it properly. Okay, so now with that we have a better understanding of order of operations. I am going to calculate this, hopefully with a few less steps, but we'll see how it goes. Let's go ahead and plug everything in. So the P is going to be 30. That's original amount. The rate is 0.05 divided by 12. We're going to times that by NT. So if NT, right, if it's N, if it's 12 times the time, it's just going to be 12 times 40, which will give you 140, right? Or no, excuse me. Should be 480. Okay, 480. So we're going to plug 480 here, track 1, and we're going to divide that by the rate, divide it by 12, right? Because n is 12. Okay, so when we do this, okay, when we calculate 0.05 divided by 12, we get 0.00416667. We're going to add 1 to that, and we are going to get 1.004, all right, in a number. Okay, and we're going to raise that to the 480th power. Okay, and then of course the bottom here, 0.05 divided by 12 should give me 0.004, etc. I'm going to use whatever values that are given on the calculator. Don't truncate or round anything up. Okay, so when you do 1 point, 0.004 to the 480th power, times it by 30 and subtract 1, you will get a number. Divide it by the bottom number, right? And you should get a value of 45,781. So practice, take a calculator, type in 1.004, hit E to the Y button, then do 480, type in 480. You'll get a number, take away 1, then times it by 30. Whatever number you get on in the numerator, divide that by 0.04444, whatever the digits are after that. Keep the number very accurate. All right, and then you should get the value that I just showed, okay? So A equals that value. All right, so now after 40 years, that's what the annuity will be worth. And then for part B, remember this is part A, and for part B, okay, let me just do it on the next slide. Part B is the interest is the difference between the value of the annuity and the total amount deposited. So the total amount deposited over 40 years is $4,400. Okay, so how did we get that? Okay, well, if you think about it, all right, we're gonna do okay, the total amount deposited is calculated like this, because we need that value to take the difference of the 45,781 with the value from this to get the interest, okay? So we take, if it's $30 a month, okay, $30 a month, right? And there are 12 months in a year. So you do 30 times 12 and you get 360. So it's 12 months in a year and you get 360 months. And then you take the 360 times 40 years, you should get $14,400. So in order to get the total amount, in order to get the interest, the value, the interest, that's added to this, right? You do $45,781. That's what we got previously, right? Right over here. And that's the future value. Okay, so we're going to take the difference of these two numbers, and that should give us $31,381. Okay, and that would be the interest that will be accumulated. Okay, all right, so that's that situation. All right. Now let's go ahead and find the periodic deposit, okay, and then we'll find out how much the financial goal comes from the deposits and how much comes from the interest. All right, so we need some information before we do that. Okay, the periodic deposit. Okay, we don't know. Okay, we don't know what it's going to be per year. That's what we're finding. We do know the rate is going to be 0.07, so it's 7%. It's going to be 0.07 when you convert it to a decimal. And time is going to be 16 years. The financial goal is going to be $130,000. Okay? So this is the formula. If it's more than once a year, then we use the following formula. Okay, so we know some information. We know A is going to be 130,000. Right, that's from this. We already know the rate, we know the time. N is going to be 1. Okay, because it's compounded annually. Compounded annually. All right, then we just plug everything in the formula. Okay, so here we go. We are going to have 130,000 times the rate, which is 0.07 divided by n. N is 1. Okay, divide that by 1 plus 0.07 divided by 1 times 1 times t. Well, 1 times 16 is just 16 minus 1. Okay, so we do all these calculations. Let me do a couple of them. All right, let's do 0.07 divided by 1 gives you 0.07. And we're going to times that by 13,000. This gives us 910. And then we'll do the bottom. We'll do, if we do 0.07 divided by 1, we still get 0.07 plus 1, which is 1.007. Okay, we're still going to raise that to the, sorry. Okay, this is going to be raised to 16 minus 1. Okay, so when we do that, we are going to get, let's see, 1.007. We are going to raise that to the 36th power. Okay, and we subtract 1. Okay, hopefully this is... Alright. Again, it's going to be 0.2854. And when you do 910 divided by that, you should get $4,662. So you would have to do the periodic payment of $4,662 at the end of each year. Okay? And then if you want to do part B, this is part A. Part B, if you want to find the financial goal that comes from these deposits per year, how much comes from the interest? So the interest is the difference between the value of the annuity and the total amount deposited. So the total amount deposited over 16 years is $74,592. Okay? And remember what I said, you take $4,662 per year. If you times that by 16 years, okay, you're going to get the value of $74,592. Then you take the difference of the original amount, okay, which is 130,000. The given amount was given up here, remember? And we're going to multiply, we're going to take the difference of the amount over 16 years, which is $74,592, and that's going to come up to $55,408. Okay. So therefore, $74,592 of this 130 comes from the deposits, and all right, so this comes from the deposits. Okay. And this number is from the interest. All right. So that's how you do that one. Okay. So I hope this video was helpful in you getting the basic ideas of these situations. Okay. Thank you so much, and I hope this video was very helpful. Thank you. Goodbye.